Hello.
Oh, hi.
Yeah, hi.
Okay. I'll make you co-host.
Yeah.
Yes, you can start.
Okay. Yeah. So basically, in last 4 or 5 lectures, we have discussed these 5 6 topics like MILP solver, deep poly, how MILP is being used. Right. We discussed PGD attack. Then we discussed alpha crown. Then we also discussed some kind of installation and uses of the tools. If anybody has any question, any problem, any trouble in installing the tools, we can discuss today. Today's session is more on question answers instead of
Yeah, correct. So I
yeah,
requested Afzal to come and kind of summarize and take any specific questions. The only one question I had, the last thing that you discussed about installation, it was
right,
not
right.
for Marabou, it was for Alpha Beta Crown as well, no?
Yes, yes. In last session it was for alpha beta crown, but
Earlier you took for
earlier
Marabou.
I used Maravo also.
Uh, yeah, I mean, Afzal is prepared to be here for half an hour, you said, correct?
Right,
So,
right.
yeah. So, I mean, feel free to ask any questions. I mean, it is okay if you have not, understood. So, one of the things, I mean, if they are kind of shy to, I mean, to just to help them warm up towards any questions that they may have. Uh, Afzal, if you could
Yeah.
show them that example, okay, the running example that you used, okay,
Okay.
kind of tell them what, in order to kind of help them or force them to uh, do something, some exercise, okay, that way they
Okay.
can force them to force them to listen to your notes and then work through that example, so that how exactly lower bound upper bound can be computed given a lower bound and a given if MILP, how does the encoding work, etc. So if you could illustrate what they could do, okay, on that example to basically cover some exercise that will help them calculate some of these things by hand, okay, maybe that
Okay.
will help them. Yeah, okay, since we did not although the exercises were described in the recordings of the lecture, so
Yeah.
I thought that you could do that. Unless they have specific questions, then you could answer them. So
Yeah.
do you guys have any specific questions? I'm assuming that based on what you might have listened to Afzal's thing. If you don't have any specific questions, then I'll have Afzal just describe the exercise problem, and he could go about it, and then spend some time in telling them, recapping the installation instruction about the tool. That's all. Yeah. Okay.
Yeah.
Do you have any questions? I guess they don't. Okay. So
Yeah.
then you could start, just going through the example. Spend about 10, 15 minutes on the example describing the thing. Then installation, and after that, you'll be done. Yeah.
Okay. Yeah. So let me just recap all these topics briefly, and then I will recap the exercise which I have given in the last lecture. It will be good to go through it, and you will understand the difference between alpha beta ground and deep poly, and how alpha beta ground is better than deep poly, right? So in the end, we basically have some neural network verification problem, right? We have some precondition, let's say phi, and we have some post condition psi, and what we want to verify for all x, if x satisfy precondition, then uh, output of x, which is let's say nx, will satisfy the post condition. This is what we want. This is the overall query. And many basically specification, for example, robustness, fairness, and all such kind of problem can be encoded in this format, right? And how this usually solve, instead of checking for all, we try to find out if there exists any x prime which satisfy the precondition and doesn't satisfy the post condition, right? This is what we ask. And now here is the challenge is like if such x is satisfying the precondition, how to basically encode. See, all these things are nothing but the formulas, right? First order formula or linear for I mean linear constraints, not linear, some constraints, and some satisfiability check. Now we can encode phi x, because phi x can be some kind of ranges, some kind of bounds. Similarly, psi, which is the post condition, it can be, let's say, some robustness, which is saying if for all I, if c is the correct classifier, then yc should be greater than every other yi. Right. Now the challenge is how to encode nx, how to encode the constant for neural network. Right. So to encode the constraint for neural network, if we see the neural network is nothing but the collection of neurons, right? And neurons are linear and non-linear kind of neurons, right? Let's say there is single output and there's some three inputs, right? These are the input. So these are linear constant. Linear constant means there is no activation, and linear layer followed by activation layer. Right. One simple example we have seen before also, if I go through it, yeah, yeah. For example, this one. This is very simple example, right? We just want to verify this. So here our precondition phi was, or let me just copy it from here. Right. So here our precondition this phi was for all x, which is basically x1 and x2, it was like x1 is less than 1 and greater than minus 1. Similarly, x2 is greater than minus 1 and less than 1. Right. And psi is, which is the post condition we want to verify, is x7 is less than equal to x8. Right. Now, we need to encode each neurons, right? So x3 we can encode like x3 is equal to x1 plus x2. Similarly, x4 is equal to x1 plus x2. So these are linear constraints. So these can be easily encoded. Now, when we come to x5, how we could encode it? We can encode it like x5 will equal to 0 when x3 is less than equal to 0, right? Or x5 is equal to 1 when x3 is less than equal to, sorry, x3 is greater than equal to 0. x5 is equal to x3. Yeah. But the problem is, since these are the nonlinear constraints which create the disjunction, when we solve by using these constraints, let's say we are solving by some SMT solver G3 or something, it doesn't scale for large network because of these constraints are called LRA, linear real arithmetic, and mm, uh, to solve such constraint, we use simplex kind of algorithm, which works only for conjunction. And if there are, let's say, one disjunction, then simplex need to call two times. If there are two disjunction, then simplex need to call four times. So it basically complexity increase exponentially. Then we go for MILP solvers. MILP solvers also has the basically this exponential complexity, but they are somehow optimized. They are better than SMT solver, and instead of using disjunction, we introduce the binary variable in MILP solver. Right, so they are better than SMT solver, but again the issue remains same. Each nonlinear activation produce uh, exponential complexity, right? So to avoid it, we go through the deep poly, right? So what deep poly is, right?
Wait a
We
minute, the
basically,
MILP encoding that you showed,
yeah,
also in order to help it constrain the search, you would have to specify some L and U, correct? Okay.
yeah, we have to
How we
specify some bound.
but that you could they could do that. Okay. That
Yeah,
is the first approach. Now you're going to deep poly. Okay, fine. Yeah.
yeah.
Yeah. One of
So,
the
so the
exercises
thing is
could
this
could
SMT
be
solver
for them
and
to
sorry.
no, one of the exercises for them could be to come up with an MILP encoding for this entire example. Yeah. Okay, so that they could do.
Yeah, and this actually we have shown in one hands-on tutorial about MILP.
Yeah. Okay. Mm.
Yeah,
And if they
we also
did
have
come up with
shared
that,
the files, Python files also about the encodings.
yeah, what Python files? I didn't get that.
Uh, I mean the Python files for MILP encoding. I mean
Huh.
we have shown how we can import the complete network into MILP
That you
solver.
had it. Now you have uploaded that also, correct? Huh?
Yes, yes, yes.
Okay. Yeah. And if they wanted to, and that has, they could run that Python code that produces the encoding, is it?
Yeah,
Hello?
Python code. Yeah, Python code itself has encoding actually. Let me just show it.
Yeah, yeah, that's okay. I mean, you just don't
Yeah.
need to show it again. No, no, but
Okay.
just to summarize, that's all. Okay.
Yeah,
So
yeah.
if they,
Python code is nothing but the encoding of the neural network in
yeah,
MILP solver.
encoding of the neural network, it does not
Yes.
produce the MILP encoding.
No, 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 no. We manually encoded this particular neural network.
So what they can do as an exercise to find out, is to have this MILP encoding for all the ReLU nodes. No? So in this example,
Yeah,
they could do, yeah, okay,
yeah.
and then maybe they can then if they have to invoke an MILP solver. I mean, is there something that they could do just to try the MILP
Yeah,
solver?
yeah, yeah. To run the MILP solver, basically they need to use. I mean, they need to get the license. So there are many MILP solvers, but
You said Garobi is one, no?
Groby is one, and I'm telling Groby because I'm familiar with
Yeah, I
Groby.
think in
I can
one
help
of
it.
your
Yeah.
previous installation thing, you said how to procure a license for Garubi, right? University
Right,
has.
right, right.
Yeah.
Yeah.
Okay. So they could. You just summarizing it, so they'll have to go and then check that thing. And maybe
Mm.
you could. Yeah. So as to how you got it, you have already shown
Yes.
that. Okay. Go ahead. Yeah. Now
Yeah.
about deep poly. Yeah.
Yeah. Just Yeah, sorry. So now the thing is, uh, if we draw the, let's say, value function, right, it will be something like this. Right. Suppose we have y is equal to max of 0 comma x, it is x, it is y. Right. So this encoding and all is fine, but why basically this exponential complexity was creating because of this choice we are getting here. Let's say it's somehow we are getting some lower bound and it is upper bound, right? So because of this choice, this value has piecewise linear. One piece is this, one piece is this, right? So they have to explore both. And if there are, let's say, 100 neurons, then there will be 2 to the power 100 number of choices. Choices are basically increasing exponentially. That was the issue SMT solver and MILP solver was struggling, right? So now we need to provide, basically we have to do some approximation and provide, remove this choice, right? And how we are removing this choice is as follow. Uh, we can say instead of getting the no, so okay. Uh, I mean, what are the possible behavior, right? Possible behavior is either y is equal to 0, right? Or y is equal to x for some range of x. And we need to explore both, right? Now we introduce some approximation and remove the choice. The approximation was this thing, right? This is, we usually call it the triangle approximation. And we are saying consider the full area of the triangle, right? Now the choice is removed, right? We have the constraint y is less than equal to mx plus c for this line, and y is greater than equal to 0 and y is greater than equal to x, right? But now we introduce some extra information, for example this point here, right? What this point is saying, this is saying ki x is equal to uh, x is some negative number and y is some positive number, which was not possible here, right? So because of this extra information, now we can provide one way guarantee. I mean, we can say if the property is verified, we can say the original property is verified, otherwise we can't say anything. And this basically this guarantee usually says as the soundness in verification community. Now the problem is it is difficult to maintain two lower bounds, and Deep Poly come up with some alternative, and they said why to maintain two bound, instead let us maintain one bound, one lower bound, right? And they were saying ki instead of these two, let us maintain either this one, right, or maintain this one, this one, right? So these are two possibilities. One is this black uh, lower bound, this one, right? One is this one, and one is this this triangle, right? Although it is I mean it is they have introduced more noise in comparison to previous triangle one, but it is very fast because now they are handling only one lower bound, right? So we also basically ask as an exercise, if in deep poly if we maintain two lower bound, then what would be the issue? And the issue was the bound. I mean, lower and upper expression are blowing up exponentially, right? So I think I should draw it separately, right? This is one case for ReLU. This is one approximation, right? Suppose this was the ReLU, right? Another possibilities was, this is ReLU, and another possibilities is, this is upper bound, and this is lower bound, right? And yeah, so deep poly provide this approximation, and it was very fast in comparison to previous one. Now they also introduce another approximation, which is called alpha crown,
Now, in
right?
deep poly,
Yeah,
so it determines automatically which one it keeps. It only keeps one of them,
yes,
the area. Yeah,
yeah, sorry, I forgot it.
yeah.
So
Now, if
it,
they
it determine
want to do that,
automatically.
no, no, just one. If they want to
Yeah,
experiment, okay,
yeah,
if they kept, maybe for that example, they could use one of these approximations and see what the output bounds will be, no? And then,
yeah.
yeah, maybe they could do either by hand or, I mean, I don't know if deep poly, yeah, I mean, or they could try deep poly or crown. I guess this feature they can actually, within alpha beta crown, if they implement alpha beta alpha in alpha crown, they can actually experiment with this deep poly, or they'll have to install deep poly separately to.
Uh, in alpha beta crown, I don't think they can choose deep poly separately.
They can, okay. They can give some option to make it use deep poly alone, huh? The abstraction.
Yeah, but there is another implementation of deep poly, which is called in ERAN. Let me just show
Uh,
you. In the ERAN, there is a clear instruction how to use deep poly.
hmm.
Let me show you. This is Jonopo. And people can use network from here. And there are lots of network to experiment. Like you can download either one from here. Yeah, so in the configuration, when we run the this tool, there is an option either use deep poly or deep zono. If you use deep poly, then they will run the deep poly as an abstraction.
As an option they can use.
Yeah, yeah,
Okay.
yeah. In the domain, instead of deep zono, we can provide deep poly.
Hmm.
But this tool is little bit complicated to install. There are lots of library to install this tool.
I see. Hmm.
Yeah,
That's it.
and
Yeah.
by
Hmm.
default, they have provided the installation instruction for Linux only.
Okay, so let's move on.
Yeah,
Yeah.
yeah. So if we see here, the lower bound deeply provide either y is equal to 0 or y, sorry, this either y is greater than equal to 0, which is this line, right? Or y is greater than equal to x, which is this line,
Hmm.
right? So if we say it is y is greater than equal to lambda comma x, where we can say lambda is either 0 and 1, right? Now these alpha ground people were saying ki why to maintain only two lower choice. I mean why to give choice only two, lambda is equal to 0 or 1. Why can't be anything between 0 or 1? It could be something like one bound will be, one expression will be something like this, right? One expression will be something like this, one expression will be something like this. There are lots of choice. And they were saying choose the one which minimize the final loss. Everyone see, if lambda is, let's say it is in between 0 and 1, right? So every possible values of lambda provide the approximation, over approximation, which
Yeah,
is the
just a
sound
side comment.
approximation.
Actually, the
Yeah.
lambda is alpha, right? That's
Oh,
where the
sorry, sorry,
alpha
sorry. Yeah.
alpha
Yeah.
name comes from. Okay.
Yeah. 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 Let me just replace it. Yeah. Yeah.
Okay. Thank you. Yeah.
Right. So for it, so every possible value of alpha is provide the sound approximation. Right. So now they are saying ki choose the one which introduce the less noise globally. What I mean by globally, suppose they want to prove the property ki y4 is the on the output of the network is greater than y3, right? So they need to prove y4 minus y3 is greater than 0, right? So choose the one which provide the higher value of this expression, right? So they are not like they experiment with every possible value and then choosing it, but instead of doing it, they provide it as an optimization query and using gradient based algorithm to optimize it, right? So basically, they convert it into a loss function, let's say L, and they were computing del L by del alpha, alpha bar, because there are many alpha, right? And using gradient based algorithm to reduce to increase this expression, and choosing the value which provide the highest value of this expression, right? These will be our alpha. So those alpha value can be 0, in that case it can be this. Alpha value can be 1, or it can be anywhere in between, in that case either of these choices, right? So it was very I mean by using this optimization, basically this they have improved a lot in terms of precision. Now we provided one exercise here also. So on this, so okay, one more thing I wanted to explain. They were using gradient basically for the scalability purpose, right? If there are big network and they can optimize with respect to alpha. But we have given the exercise on toy example, and we were saying try to optimize the loss for some alpha, right? So for which we can use basically MILP solver also. So on that particular example,
Hmm.
on this particular example, this is the example of from the deep poly paper, right? So instead of like here, they are choosing y greater than equal to 0, right? Y here is x5, right? So instead of this, we can provide the x5 is greater than equal to alpha dot whatever is the input x3. Let's say alpha 1. Similarly, here we can say x6 is greater than equal to alpha 2 dot x4, right? And alpha 1, alpha 2 can be any value between 0 and 1. Right. Similarly, for x7, we can say something. I mean, here x7, I mean x9 is already in active phase, so we don't need to provide any approximation. But here we can say something, right? Instead of x10 greater than equal to 0, we can say x10 greater than equal to alpha 3 dot x8, right? So it will be x10 is greater than equal to alpha 3 dot xz, right? So by using this alpha 1 in alpha 2 alpha 3, finally suppose we need to prove this thing, x11 minus x12 is greater than equal to 0. So we can maximize this expression and keeping the values of alpha between 0 and 1, right? So the exercise I put last time, I was asking, so these are the expression generated by deep poly, right? When we are maximizing it by MILP solver, it might be the case that alpha 1 will be some value, let's say 0.01, alpha 2 will be 0.5, and alpha 3 will be 0.8. So I ask, what are the value of alpha? And when I say value of alpha, it is nothing but the lower expression. When alpha 2 is 0.5, then it is nothing but x6 is greater than or equal to 0.5 into x4, right? And then what is the final value of it, right? Suppose by using deep poly, we were getting it, let's say, uh, 0.5. It might be the case by using alpha crown, we'll get it 1.2 or something. If we are getting higher value, it means alpha crown is improving it, right? Or maybe by using deep poly, let's say we were getting x1 minus x2 as minus 0.5. In that case, we failed to verify the property. Maybe by alpha crown, we will get some positive value. In that case, we can say that this is a verified case, right? So, yeah, I again ask a student to run this example on alpha ground by using MILP solver as an optimizer.
Hmm.
Then it will give the sense how alpha ground is improving on top of deep poly or ground.
So in that tool,
Yeah,
what
yeah.
option do they have to use in order to run this?
So this particular example, we don't. People don't need to use any tool.
Ah,
They can directly run MILP encoding.
ah, okay.
Yeah. So this expression will remain same. Only this expression will get changed
Mhm.
when the ReLU on the ReLU's expression, right? Like I said, instead of these two possibilities, by introducing alpha, we are providing infinite number of possibilities, and each possibilities is providing over approximation.
Yeah, but they're not doing it by hand. You are asking them to use the MILP solver to find the alpha, correct?
Yes, yes, yes.
Ah, for which they'll have to use which tool is what I was.
No, no. What I'm saying, these are the constraints given. Let's say these are for
MP,
linear expression. These are the constraints given
or
for
you directly
ReLU's.
feed it to an MILP solver, that problem.
Yes, yes, yes. We
Okay.
can basically put all these conditions into
Okay.
MILP solver. Only the change is here. Instead of saying ki x5 is greater than or equal to 0, we will say x5 is greater than or equal to alpha 1 dot x3.
Hmm.
Alpha 1 can be 0. In that case, this is the x5 will be become greater than or equal to 0. Alpha 1 can be some value also. So alpha 1 can be between 0 and 1. Similarly for x6, then x7 will have the same expression. X7 is equal to x5 plus x6. X8 will be equal to x5 minus x6. And similarly here we will update the expression in terms of alpha and then the final expression. Then when we optimize by MILP solver, we can just say ki maximize x11 minus x12. When it optimize it will produce some satisfying value. It will produce the value of x1, x2, x3, x4, everything. Also the values of alpha 1, alpha 2, alpha 3. So these alpha 1, alpha 2, alpha 3 are nothing but the slope of our lower expression, right? Is there any question here?
So
No, you
by
can.
finding alpha values, we
Yeah.
mean for a specific instance, right? A specific neural network over which for all the neurons, all the steps we find the alpha
Yeah, I mean, this is the neural network given.
for this neural network. We find all the alpha values. That's the
Yes, yes.
exercise.
Yeah,
Uh,
yeah,
yes, sir.
yeah. So I would say, see, uh, whatever is the written, right, from the paper, I took this screenshot from the paper. This is the deep Polish expression. Just a minute. So these are the values from deep poly, right? So, and we are getting this expression, right? So let us say by using deep poly, we find the value of this expression. We will get some values of it, right? By using alpha crown, we will get some better value. Better value means some value bigger than deep poly, right? So what I'm saying, just find the alpha values
For the
as well
lower
as
bound,
how much you are improving.
it can give you uh, better values for lower and upper bound as expressions, correct? Yeah.
Yes, yes. Right, to find the alpha values as well as compare the final value of x1 minus x12. So it
Yeah.
will basically give you the sense how much you are improving in comparison to deep poly and why it is improving. It will improve because of some change in the alphas,
Yeah, which
right?
means
Here,
we'll have to first get an encoding, I mean, expressions in terms of alpha 1, alpha 2, etc., introduce that,
right,
and then
yeah,
feed the entire thing to MILP with the objective function of sum at the output, and then try to get values for alpha and alpha 2, etc. Correct? Yeah.
yes,
Then
yes, yes,
compare the lower and upper bound with
yeah,
what deep poly does. Yeah. Okay.
yeah, right.
Okay. Any questions? If not, then
So
proceed. Yeah.
yeah, and yeah, that's all. We also covered PGD attack, which is nothing but if this is a neural network, let's say, and this is some property we want to verify, this is some input. So they convert the property into loss function. Loss function, which is the negation of the property, right? And they compute the gradient del L with respect to the input, let's say x prime. These are the input, right? And shift the value of x. Let's say suppose this is the x. They just shift the value of x such that they violate the property, right? So they can shift in each iteration. It will be something like this, and at some point they will violate the property, right? So it's a heuristic. It doesn't provide any guarantee, right? If suppose if they fail to find the input point for which the property is violating, we call such point as a counterexample. Suppose if PGT attack failed to find the counterexample, then it doesn't mean there doesn't exist any counterexample. right? So it doesn't provide any guarantee, but it is very, very impactful. I mean, more than 95%, 90% cases, you will get the counterexample by using PGD attack.
Real counterexample. Hmm?
Real counterexample, yeah. Yeah.
Yeah, yes. No, I have a question here. So there, why is there, I mean, for the class, I'm saying, we you
Yeah.
discussed this. The PGD attack cannot provide a precise answer, correct? So if it
Yes.
provides that there is a violation, then there is a potential violation, correct? Yeah, that you need to check if it is a real violation or not, isn't it? Correct? Yeah.
No, no, I couldn't get, sorry. What is the
No.
question?
Is the PGD attack answer that if you use the PGD attack, okay,
Yes.
option,
Yeah.
if it says it verified,
Yeah.
or is it can the answer be is viewed as precise? Okay.
Yeah. So the thing is, it won't say about verification. Only thing is, it can either provide a counterexample or unknown.
Yeah, and I was going to ask them why it is that is the case, and I will answer. I'll think I'll answer based on my understanding, because they are all dependent on loss function minimization. Okay,
Right, right, right.
means that is based on some sampling. Therefore, there is always a certain accuracy. Correct. So
Right, right. So there will always possibilities like it can miss some point.
correct. Yeah.
There are infinite number of points. It can miss some point. Maybe there's some real counterexample existing here. It can come near to it and miss it.
Yeah.
It is possibilities.
Yeah. But if it says that there is an error, that is
Then
it.
it is error,
It
right?
is an error.
And why we are using PGD attack at all, right? So the
Mm,
thing is like deep poly, crown, alpha crown, they are sound approximation. They only say about the verification, right? If
mm, mm.
they verified, then they can say it is verified. If
Correct.
they fail to verify, then they can't say anything.
Mm,
So if they fail to verify, either we have to use the exact solver, which are MILP solvers and all, which are very costly in terms of computation,
mm.
or we can use PGD attack kind of thing, which basically try to search the counterexample.
Okay. Yeah. Please go ahead. Yeah, I think, yeah.
Yeah.
I know
So
this is an overall summary in that you're doing the exercise. Okay. So the recording
yeah,
class, I'm saying, the recording will be there, and the installation. I don't know if we'll get some time today or not to summarize, but the last class's recording will have installation. And if you need more things, you can always reach out to us, or I say use some chat GPT and find out more about this thing based on what you've learned so far. Use chat GPT, and then
yeah, it will provide very good response
yeah, and
because
I'm sure
yeah,
it'll provide. The expectation will be that some questions on this will be there in your exam, okay, and for your next assignment, which is the digital recognition system, you will be using. You'll be expected to use alphabet or crown, okay. So
yeah,
anything, if you have doubts, etc., you can either reach out later, or use ChatGPT, okay. But what you will be required will be specified in the in the assignment, and you'll be expected to do. Okay, go ahead, please
yeah,
go ahead.
yeah. So let me just put its GitHub link here. And if people try to install it, if face any issue, just either try to solve it or reach out to me. I will be available. Similarly, for Maraba, yeah. So if you face any issue, just reach out to me at this email ID. Yeah.
Yeah, I mean, finally, I guess you didn't say what exactly alpha beta crown has, uh, more than alpha, that alpha crown does not have. What is the beta? Okay.
Yeah, I mean, this is I didn't explain, but I at the high level I just say what is beta
Yeah.
crown, right? So like okay, so like deep poly crown, alpha crown, and all these things, they are just providing some approximation, right? So what beta crown do, and many other techniques actually in this neural network verification, if they fail to verify the property, at the same time, let's say PGD attack is also failed to find a counterexample, then what should we do? Should we report it as unknown, or should we do something more?
Mm.
So this beta ground and many other people, they try to find out which neuron actually responsible for this unknown answer, right? And they try to remove the approximation from that particular neuron. So when they remove the approximation,
When you say
then
they
this,
remove, the approximation will be removed, but they'll be replaced with what?
yeah,
Actually.
that's what I'm saying. Yeah, when
Okay.
they remove the approximation, the ReLU again become exact ReLU, right? Then again there will be choice, right? So what they are doing, then they create two possibilities here, right? We are
Mm.
calling it as branching. One is
Mm.
active ReLU,
Mm.
another is inactive ReLU, and they solve two subproblems in parallel, right? If they
Ah.
found the counterexample in any one, then they will report it. If they
Mm.
verified both, then they will say it is verified. If
Mm.
it is still unknown in both, then they further pick some value and do this branching.
Mm.
Yeah, so this is what the beta crown is.
Mm.
Sir,
Yeah.
what stops this from becoming exponential or like as inefficient as Reluplex?
Yeah, so in worst case, it become exponential. We can't stop it. But the thing is, okay. But the thing is, the way they have implemented it is very efficient in comparison to Reluplex.
There's also parallel implementation, right? I mean,
Parallel implementation and all this branching and parallel verification, it run in PyTorch, Tensor, or something, and they have accelerate on its GPU. So that is the plus point. I mean, the way they have implemented and their technique, this branching heuristics, they are accelerable. They are implementable in PyTorch and accelerable on GPU. And all these branching and all they have implemented in matrices, right? Which basically, which is very very fast.
mm.
In worst case, this number of problem will become exponential. This is right, but they are choosing the ReLUs by using some heuristic, which is basically the case. Choosing, let's say, okay, so there are 100 ReLUs, and let's say they provide some kind of ranking on the ReLUs. Ranking one means if we are removing this particular ReLU, then it will basically reduce lots of precision.
Mm.
Ranking 2 means it will remove the precision but lesser than the rank 1 relos, like
Mm.
this. And they're picking, let's say, top 5 relos and branching on top of those top 5.
Mm.
Most chances they will either verify or find a counterexample. If they fail to either verify or find a counterexample, then they again pick more 5 relos, like this.
Sir,
In
so
worst case, it
unlike
become
Reluplex,
exponential, but in most practical cases, they will stop. Sorry, what was the question?
uh, sir, so unlike Reluplex, here we are being very sparing with our case splits, whereas in Reluplex it has to be done almost every time. Is that what makes this much more efficient?
No, so the thing is, see, picking the ReLU, right? In approximate picking the ReLU, there are, if I can say, 10 to 20 paper around it. They provide each different kind of heuristics, how to pick and how to use, how to pick, how to use. But the question is, if they are picking some ReLU. In ReLUplex, the limitation is if they pick, let's say they have some heuristic, they pick some ReLUs, but they can branch and run each sub problem on CPU only in parallel, let's say, which is okay, but not in compared to alpha beta crown. In alpha beta crown, they are picking ReLU, branching it, and running both sub problem, not as a sub problem, but as a some matrix multiplication and optimization on this matrix, on these matrices, and they accelerate on GPU. So this is the plus point of alpha beta crown.
Mm. Yeah, and another thing is that they're using finer approximations that they're using. See, in ReLU, of course, you could use the same heuristics to choose which ReLU that you use to refine. Okay,
Yeah.
when you don't, but then it's kind of all or nothing. No? I mean, it's either precise or nothing. Okay, not precise. Whereas here they are able to use this triangular optimization. Correct? I mean, approximation, which is not there in ReLU, right? So
Yeah,
that
yeah.
difference is there. Yeah.
Especially this alpha crown, which is very effective.
Mm. Yeah, but that's a good point. The Dhruv points of, that in the worst case, the branching can overwhelm it. But with all the engineering that goes into its implementation and its GPU implementation, then
Yeah.
in practice it works. And the heuristics of which ReLU that they pick to split on. Okay.
So the
Make
thing is,
the
all
difference.
complete tools, na,
Mm.
all they have worst case exponential complexity.
Mm.
What I mean by complete tools means they either provide a verification or counterexample.
Mm.
Means if their verification fail, PGD attack fail, then they run branching and solve this problem. All they have exponential time complexity in the worst case. But they are beating each other in the sense of their implementation, their engineering, and their heuristics, and all these things. Right.
Is
Okay,
there
good.
a possibility of doing eventually better than EXP? Or
Sorry.
like, is there the eventual possibility of going better than EXP?
No,
No,
sorry, I couldn't
Dhruv.
get the question.
No, 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 no. He's asking if there is a way to reduce the worst case complexity better than exponential. See, that is not possible, theoretically not possible, Dhruv, because you remember that, very early on in the class. And I also, showed there is, one of the early, if you go back, the DNN verification problem, if you want to solve it in a sound and complete way, it is NP hard. Okay.
Yes, yes.
Because, and therefore, how can you get it better than thing? Because you can encode the Boolean satisfiability as, in terms of neural network with ReLU. Okay. Therefore, the worst case complexity, and since Boolean satisfiability is NP hard, it is futile to even look for a verification method that is whose worst case complexity is better than exponential. Okay.
But here we are using some approximation where the
No, no,
there is
yeah, but then that is a different thing. Yes, okay, using some approximations, of course, you could do that. But even with approximation, if you are willing to live with, not a complete answer, it can either say verify or I don't know. Okay, then it's okay. But now, like, look, Afzal said complete, which means there'll be a refinement procedure. That is where the exponential complexity is coming from. Okay. So because when it says I don't know, that's when they split, okay, into it active, inactive. So then you can split everything, all the things, and then maybe you can come up with a precise answer. If you do that, then you get exponential complexity. Okay, that is kind of roughly what the answer is. Yes, you will be able to come up with some better methods if you're willing to live with not a
Hello?
precise answer. Yeah. Okay. Is that
Sorry,
yeah?
my internet was interrupted in between. Is there any question?
Yeah. No. That's okay. No, we have only 10 minutes. No. There was some discussion. Yeah, a discussion about whether you can do better than the worst case complexity can be better than exponential. Therefore, I was explaining to him
Right,
that
right.
if you want to
Yeah,
do precise verification, since the Boolean satisfiability I had shown earlier in the class that it can be encoded as
right.
neural network with ReLU, and therefore the worst case complexity is exponential, since Boolean satisfiability is NP hard. But then Dhruv asked the question, oh, if you don't want, okay, if you do approximation, then can you do it? Of course, with approximation, if you don't have refinement, then you can do, if you're willing to live with an unknown possibility, okay? Then maybe you can get something.
like the police complexity, it has some polynomial complexity.
The polis is polynomial, huh? Yeah.
Yeah. But at the same time, it can provide a non-answer also.
Yeah, it can. Yeah. Okay, so that was what the discussion is. Okay, so in the 10 minutes that I have, any questions so far to Afzal?
Oh,
Okay, so then,
sir.
yeah, if there are questions, then why don't you reach out, Dhruv? Because I have to, say a few things about some administrative thing, okay? And I have to catch
Yes,
this 6 p.m. Shuttle. And therefore, let me, if I can share the screen.
So shall I leave then, or do I have to?
If, yeah, I guess you could. Or since only 10 minutes, why don't you hang around? I'm going to talk about the papers.
Yeah, I'll be here. Okay.
Yeah. Okay. Yeah, okay, here's what the thing. Okay, so I'm looking at, you see, you will have to select the papers, okay? The papers that I have. So these are the three categories that that we have given, okay? And you will have to, I want people to select maybe, two papers. There are 10 people, so we want to discuss, I'm splitting them into 5 teams, with each team having 2 people. And, I want to cover these things, 1, 3, 4 in the first category, 1, 3, and these 2 papers in the second category, okay? So you will have to pick which category that you want to choose, and then choose your teammate, and then also see. I have not put the PDFs of all the things. We'll try to put PDF, but I'm sure you can get the PDFs on your own. But in the meantime, I can put the try to put the PDF for these LLM thing. I have put it in the link. Afzal, if you could provide PDFs for these papers in the NN monitoring category, okay, then I can
Yeah,
put it in there. I can add that
yeah,
link.
sure, I will provide.
Yeah, this one, I think I have some of them. I will do that. So, you will have to decide before next Tuesday. Next Tuesday, it will be a physical class. So there, I want all of you to show up, and I want the assignments of the paper, etc., discussed and decided. There, and then the timetable that I'm having is I'm thinking of having, we are 7th here. So I want to provide 2 weeks for all of you to read and then prepare your presentations. The presentation days, I'm thinking of having it on 23rd, April 23rd, 24th, and 25th. Okay, around that time, the last week. 23rd is a Thursday, Friday, and Saturday. Okay. Or you can do Tuesday, Thursday, Saturday. So I will send you the schedule. So you by next Tuesday, not next Tuesday. Where are we? We are now here on Thursday. So I want by 14th when we meet physically to I urge people to show up with your teammate to that class so that we can decide and finalize the assignment. Then you will have roughly a week to do that, and then the presentation will be on these 3 days. Okay. And therefore you'll have to get cracking on that. Okay. And yeah, I mean, if you have any questions, please get these papers, at least read the abstract and the intro, so you will get an idea of what the paper is about, and based on that you will have to choose. Okay. And I want to spread the papers across these 3 categories. Okay. So
Sir,
there'll be some first come first served kind of a thing. Yeah.
sir, the verification of camera-based autonomous system, is it black for any other reason than other red?
No, but that's too detailed. I see all these things are kind of related and they're complementary to each other. Okay. Who's asking this question? Can you identify yourself?
Anurag Gupta.
Huh?
Anurag.
Anurag. See, I can see this is a very complicated paper. Okay. Yeah. And
We are not
also,
doing it on all kind of systems, right? We should choose one verification.
yeah, see, but the reason I have not included, although included in NN verification, okay, this verification is not really an NN verification. It is like it's kind of using, see, these are more focused with respect to the kind of techniques that we have discussed in class. Okay. And monitoring is also somewhat related. Okay. Of course, the LLM thing is somewhat different. Now, if your question is, why have I not included that? Is that your question? Or you're saying that
No,
you're
I'm just
excited
asking if
about that
that is still
particular paper?
available as a presentation paper, like as
Huh?
a presentation topic.
I mean, based on the title, you're excited about that paper?
No, I'm just asking if that topic is available to be chosen as a presentation.
No, okay. Assume that I have removed that from that category. Okay.
Okay, sure.
Yeah. So I want you to choose preferably the ones in the red. Okay. And in LLM, both these papers. Yeah. Yeah. Does that answer your question?
Yes, sir.
Yeah. Okay. Yeah. I think by next Tuesday, if you guys would have taken the time to read the abstract and rough thing, then we can discuss further next Tuesday. So you will have some idea, and so you should express your preference and come to the class, and then we will make the final decisions. Yeah. Okay. Yeah, I think that's all I have. I mean, I'll have to get ready to catch the thing. So let's thank Afzal. Okay, class. You can unmute and then give a round of applause for his time and effort. Okay, can you do that? Unmute yourself, please. And you don't hear my thing unless you're not there. They rarely do. I asked you to, class, if you're still hanging around, unmute yourself and clap, okay? And saying, showing your appreciation for Afzal, okay? Oh gosh, they're not there. Okay.
Boundaries, sir.
Dhruv? John, unmute yourself. Anurag, unmute yourself.
Yeah, I just
You have to
Yes, sir. I can
individually
unmute,
accept
but
everybody.
clapping is a little not possible.
Yeah, okay. Okay, good. Thank you very much. Okay, you could all say thank you. Yeah. Okay, thanks very much, Afzal. And you're still available. You'll be there for the lectures, okay? And on NN monitoring, certainly
Yeah.
you can have, he knows about all, at least the first two papers in the first two categories. So you can always reach out to him as well. Thank you very
Yeah,
much,
sure.
Afzal. Yep.
Sure.
Bye-bye.
Yeah. Yeah. Thank you, everyone. I really enjoyed delivering the discussions. I mean, it was not more on lecture, but the